Howdy everybody in YouTube land. Got another amplifier video for you. As you could tell, you could probably see the fault with this one already. Yeah, okay. So, this is a Kicker ZR1000. It's an older one. It's probably from 2000, 2001. It's the one that takes the key and the key bypass has already been done on it. I may have worked on this amplifier in the past. I may not have. I've seen so many of these, so I don't really know. One thing I noticed right away that stuck out like a sore thumb is it's got this one oddball transistor out here in the middle of nowhere. You cannot buy these in this style TO3P package anymore. You can only get it in this TO247 or whatever that's called. So if you're going to do that, you got to change them all to match because these are slightly different thicknesses than these. And anyways, so I went ahead and gone through this amp, cut out all of these pins in the past, it looks like, and then someone resoldered them back on. I just said, with my hunch, I saw this one that looked out of place, so I snipped it loose. Sure enough, that one's shorted. None of the other ones are, so only this one is shorting, which is kind of weird because it looks like it happened in the past, it was replaced in the past, and it shorted again, but none of the other ones did. So either the characteristics of that one is different or something. I don't know. So I bought new ones. They're in the same style, but I'm going to change them all. That way they all match. This is a Class AB. Normally you wouldn't have to do that. You wouldn't have to do matching like that. But if you look, all the bases are connected in parallel with no resistances in between. So they're going to have to be matched as best as I possibly can. I'll check the driver transistors, which is this guy here and this guy over here. They didn't seem like they were shorted, but I don't know if they're going to break down under load or anything like that. But that's not what concerns me. What concerns me is over here. Actually, two things concern me. One is I don't know if I can get replacement of that stuff anymore, unfortunately. But more importantly, the damage. Look at the PCB. Especially right there where all the sources are. So, like, this one's okay. That one's, let's see, what year was that? That's an 064N. 2001. Yeah, they might be original. They might be replacements. I do not recall. Anyway, so the transistors have self-destructed and they've burnt the board. You can see the carbon tracking around the pins. So my concern is the carbon tracking that's in between these legs right here. If it's just going to pull out of the board, if I can even solder a new lead in there, or if the damage is already done, there's resistances in between here now. I don't like working on these anymore, and this is why. It's like, how do you get around that? Let's see. Let me just go ahead and... Oh, yeah. Oh. Roached. That is roasted. I'm going to have to replace these sill pads, too. Man, that is just bad. I'm going to hazard a guess that, well, let's see. See if I can even get, oh, man. Well, it might not be too bad. Could be surface damage. I don't know. We'll have to change. We'll have to clean all that up and see. This channel here appears to be fine, but that one's pretty bad. And the other thing too is the terminal block, the plastic's melted around the terminal blocks. So it's a mess. I've got another one of these I have to service too. These pieces are gone. And there's like a piece of one left and the rest of them are gone where they all melted. So the other thing I got to pay attention to is these RCA jacks because these pins like to break from the board. Let's see what we have here. That's just dirt. So yeah, I got to double check the pins here and make sure that they're not breaking free from the board because they like to do that. These things are so thin. and this thing gets pushed on and monkeyed with all the time, so they like to break from the board. The potentiometer has a shaft in it that comes out the other side, so yeah, this is just, that's not coming out. Let's do this by trying to loosen up. Yeah, these are junk anyway, so I don't care. Until that one got hot, because this one might have still been trying to work. Oh yeah. Oh wow. Okay. Let's see. There goes that transistor. What am I gonna find? Oh yeah, that's it's unfortunate. And those transistors have definitely been replaced before. So yeah, I'm gonna have to replace them again, I suppose. Yeah, that's really unfortunate. So the other thing I'm going to have to do is I'm going to have to find the bias specifications, because as soon as I change all those transistors, I'm going to have to rebias this amplifier, and that pot there and that pot there are responsible for setting the bias, the idle current. So I need to figure out what that looks like. But for now, let's go ahead and pull all this crap off and see where we get. Well, it actually cleaned up pretty good. I did a little bit of scraping with the, not quite the appropriate tool, but it works out for what I'm doing. A little bit of scraping, get all the flux and carbon off of it, and actually, it didn't come out too bad. So this one might actually be savable a little bit. I still got to pull all this off and, do that, but I got a big pile of parts accumulating over here. So I went ahead and pulled the transistor array out of there too, so I can go ahead and get the replacements put in there. What I'm going to do now, actually there's a couple things I wanted to talk about here. What I want to do now is I want to go ahead and start bending the leads, and the way to do that is to figure out what the spacing is going to look like so there's no undue stress on that transistor, and we can get a nice flat pressed mount into the heatsink without stressing the leads or the board or any of that. So that's why I have the board in here, just kind of temporarily in here. After that, I got to replace these sill pads because they're just completely shot. But anyways, the other thing I wanted to point out too is these capacitors right here. I went ahead and changed these out. I put a ceramic or multi-layer ceramic here. I put a multi-layer ceramic here, and I put a new electrolytic because I don't have any of these in the right voltage. And also over here is a 1 microfarad, a 50 volt I put there. The reason why I did that is because I had noticed when I was removing this chip and replacing this chip, which is the main switching IC, and it's de facto standard. When you lose these MOSFETs, you always want to change these in these amps because there's no buffer transistors that I can see. Anyway, so I noticed that this capacitor had just started leaking, just like vintage Macintosh machines and stuff like that. So that is one thing you need to be aware of as a warning, that these capacitors, even though this amp was made in 2000, 2001, somewhere in there, these capacitors are just starting to leak. So keep that in mind. The other ones didn't show any signs of leaking yet, but this one certainly did. And when I pulled it off, you could see the corrosion and you could smell that telltale dead fish smell. So I knew it was time to go. So I just went ahead and changed them all. That way I don't have any more problems in the future. But it's something you got to be aware of, because when these start getting really bad, they'll destroy all the traces and connection pads and vias and stuff like that in this surrounding area on this board. And at that point, it just becomes a nightmare. And the electrolyte will travel through the vias and it'll soak into the middle layers too. So if you've got circuit traces in the layers, which I don't think this board does, but some boards do, you'll have traces running in parallel directions with the ground planes and everything else, and you'll create parasitic capacitances. And there's no way to really fix that. Once you get to that point, it'll always malfunction. I have a Phoenix Gold that's on the shelf that I don't know if I put a video up on yet or not, or even if I did video footage, but it's the same issue. It's so old, all these filter caps were leaking to the board. It did so much damage to the traces that when I cleaned the board up, put new parts in it, it still didn't work properly. It won't go into regulation. And I verified all the circuit connections, so the only explanation for that is the electrolyte getting in the circuit board. Anyway, so just take that as a word of warning that it's time to go ahead and start changing these caps on these older ZR series amplifiers. It's time. It's time before they get bad. Alrighty then. Now I went ahead and got the transistors put in. Got all the leads clipped and all that stuff. This is just kind of sitting in here. Got the new sill pads on. I went ahead and greased up the existing sill pads here with some thermal paste just to make sure that the heat transfer is better than what it was originally. It's just something I try to do. But now I've got to get all that stuff clamped on. I'm still waiting to hear back from Kicker to see if I can order some parts from them, because I need replacement silicone thingies here. They're just all fried and screwed up. But also I need the biasing procedure, because I don't have the current specs for the idle current between both sides, because I powered this thing up on the bench already without being in here, and this side gets really hot really fast while this one kind of stays cold. So I got to get the right specs, because if I knew this was functioning in the right specs, I would just match this side with this side, but I can't guarantee that, so I'm waiting on Kicker to get back with me with the details on the biasing settings for this unit so I can get it all set up correctly. But for now, I think I'm going to go ahead and get this thing zipped back together, and then we're going to hook it up and we're going to do a sound test as per the norm. Of course, this thing takes up my whole desk, so I really don't have any place to put anything. But as you can probably hear, tone generator's on, but all I'm getting is buzzing. So, as suspected, we've got a bad ground somewhere on this amplifier, and it's probably right here on this RCA jack. So, unfortunately, I don't know. Both channels sound like they're working, though. They're just not. Man, that sucks. I'm going to look up underneath there to see if there's any broken. Okie dokie then. So. I wonder if I can. Yeah, that's a negative. Alright, well, I guess I'm going to have to dig into this a little bit further. Of course, I'd have to take this thing all the way back apart again. Why not? That's just how it is with my life. So anyways, you can see where I had my solder paste and all that, or not solder paste, heatsink compound and all that stuff in there, and I didn't feel like taking all this back apart again, so I just kind of left it say there. This plastic's broken anyways. Okay, so I metered out the RCA jacks on that side, and it's not broken. They're all interconnected. So, hold on, I need both my hands, and I don't have both my hands. Alright, so what I'm going to do now is I'm going to check right there. See that little tiny fucking fuse? Well, let's see if it's blown. I bet it is. Yep. Nothing. Open line. Yep. Bad. And usually what causes that is if the battery ground goes bad, it's going to pull ground from somewhere else. And guess where it's going to pull that ground? Yep. So this is why when you install amplifiers, verify your grounds. It's crucial that you do so. Anyways, we're going to go ahead and take care of that problem. And we'll try this again. Okie dokie then. Now it's back together. The fuse was blown up under there, so I put a new one in. This is what I had on hand. Just cut these little ceramic fuses, but it'll work for now. So now it's just a matter of getting everything hooked up so we can try this yet again. Of course, I don't have the right power supply for this kind of stuff here, but for simple testing, it'll still work. My speaker wires are still connected. Go ahead and engage this. Alright, it's drawing current. Red light's on. Protection's not on. I don't hear the relay clicking, which has me somewhat concerned. Oh, there it goes. It's just a very long delay. Okay, now. Alright, no explosions, but I did notice this amp does not like RCAs being plugged in while it's powered on. Yeah, it doesn't like that at all. Huh. Okay. Which, it's been a while since I've dealt with this, but ooh, I heard sound. Let's try. Hey, it works. One channel. Other channel. Yeah, it's on. Alright, well, I don't have a distortion analyzer or an oscilloscope or any of that other fancy stuff here, so it's not like I'm going to be able to hook a Keithley up to this thing and it's THD 0.008. I'm not going to be able to do all that, unfortunately. But what I will do is I'll let this thing run until it gets warm and see what it does, and then wait for Kicker's response on getting the stuff to finish this job up. But yeah, new caps, new driver IC, another new cap down there, new transistors on that bank, and new power supply transistors. So, yep. Oh, and new sill pads, and then some stuff on the other sill pads. But okay, so thank you for watching. I'm just going to go ahead and upload this video as it is, because I have to set this aside and wait for the other stuff to come in, but by that point it's just cosmetic, so I think we're going to end it here. So if you have a comment, please feel free to leave one.